in this paradigm, you have basically three pieces that the rat has to do. It has to figure out that the trapped rat's distressed. Then it has to down-regulate his own distress enough to go and act. And then he has to figure out the door. Now the door part, it's interesting, it's a piece of cognition, but it's not really what we're interested in. And so we'd like to get the door part out of the way, and by training them on this, letting them learn how to open the door, and then extinguishing it, then we can get the door thing out of the way. They'll remember how to open the door, and now we can ask them in an outcome-dependent way, who are you going to open the door for? So that going forward, that's going to be a useful way to do these experiments. Yeah?
Any look yet at how closely related the rats are?
Yes. So we've done, the published work was all in cage mates. And we did strangers. So we ordered them, they're the same age, but they've never met, and they get a different stranger every day. And for those guys, they open, but they're a little slower at it, and they're a little less celebratory and stuff like that. And then we had this idea that how mom takes care of the pups will influence how empathic the animal is as an adult. So we took these two litters, and we measured the mom's behavior, and then we let the litters grow up, and we tested sibling pairs, same-sex sibling pairs. Those guys are super duper empathic. But is that a test? It's a bad test because number one, they live together forever, and number two, they're siblings. So we don't know which of those two things was important. But it's one of the things that we want to look at. We want to now take the siblings and either let non-siblings live together forever, or let the siblings only live together for 2 weeks and see what happens. Yeah?
Have you done any tests where a non-caged one has a choice between opening the door for an opener or a non-opener? You know, you have two caged ones, one is an opener, one is a non-opener.
No, we have not done that. That's, so which of two animals they'll open for? We did a different experiment that kind of gets to that. Let me just show you a few other experiments. So there's two other experiments I just want to tell you about, and then we can get to all of your wonderful questions. So the easiest explanation for this is, well, the rat opens the door because the trap rat can't play with him. He's in the trap. So I want to open the door because I want to play with you. So what we did was we redesigned it. We put two arenas together, and we put the restrainer up against the barrier between the arenas with the door right here. So when the free rat opens this door, the trap rat gets let out, gets released, but into a separate arena. And they can't play. Okay? So this is what happens. They learn the regular paradigm, and then in this case they were put in with an empty restrainer, and you can see they still open for the empty restrainer for a few days, but that eventually extinguishes and they stop opening. But then if that restrainer now has the cage mate again, they start opening again. For the trap, in this situation, we just did it counterbalanced in terms of order. Here they continue to open when the cage mate is in there, and then when you take the cage mate out, they open for a long time, but eventually they extinguish and stop opening because it's an empty restrainer. So this tells us that it is not necessary for them to be allowed to play with the rat in order to motivate them. So social reward, there's just no way social reward's not influencing this behavior, but it's not required. So then, to be quite honest, we had this work reviewed by science, and they rejected it. And I studied their rejection for a long, long time. It was pages and pages of little details, little nitty-picky, ooh stuff. And I just read it over and over again. And finally I decided they just don't believe us. They need an in-your-face experiment. And so what we did, we had at the time some rats that were eating chocolate for a different experiment. And so we said, okay, give them a choice. Chocolate or the cage mate. And so what we did was we put 2 restrainers into the arena. One had 5 chocolate chips and one had the trap cage mate. Now these rats they've been trained to eat, or they've been exposed to chocolate, which is what it takes. So they're exposed to chocolate, they're eating the chocolate, and we give them a little bowl of about 20 chocolate chips, and on average they would eat at least 7. Their average in a meal would be more than 7, and we're putting 5 in the restrainer. So what happens? Well, once they learn how to open the door, they open for the chocolate and they open for the restrainer at not different latencies, which tells us that releasing the cage mate, the trap cage mate, is on a par with chocolate. However good chocolate is, it's on a par with that. And that's not the case if the other restrainer is empty. So that was great, but then we noticed, it's like, okay, look at who's eating the chocolate. And I had a bunch of students go back and we counted every bloody chocolate chip through the videos, and it turns out that the free rat was eating 3.5 out of the 5 chocolate chips, and the released rat was eating 1.5. In the other condition, they're eating all 5 chocolate chips. Now, this is, I will honestly tell you, the only finding that we had in the entire study that surprised me. Why did it surprise me? Because my sister-in-law will not share chocolate. Okay, so the idea that a rat is sharing chocolate, this is unbelievable. I actually still don't particularly understand it. So, and what's furthermore, there are so many ways he could hog all the chocolate, and he doesn't. He shares the chocolate. So even if he opened for the trapped rat first, it takes the trapped rat a moment to get out of the restrainer so he can, he's cutting out? Okay. So he can race over to the chocolate containing restrainer and open it while the trapped guy is still trying to figure out how to get out, but he doesn't do that. Okay? On average, 1.5 chocolates are left for the trapped guy. So that's really exciting,
Excuse me,
Yeah.
do you have any evidence that rats eat more chocolate when they're stressed?
That's a good question. That's a good question. I don't know that. I don't know if the answer to that.
Then that might be a good measure.
That's a good
If that
question.
cortisol
I don't know.
level-
I don't know. That's a good question.
It probably depends on the periodicity. So,
On the what?
periodicity of the stress. And so following an acute, they might, take a while to tampen down from it and then have like a compensatory, chocolate gorge.
Yeah.
Under the chronic stress scenario, though, later in your study, they haven't spiked in their cortisol already, so that part probably isn't there.
Yeah. I mean, stress is not their friend in this paradigm. When we stress the animals, they do not perform well. And we have a couple of studies that we did that inherently require some stress. So, for instance, just a saline injection. It's not horrible, but it's not something they love either. And the number of openers goes down to 50% instead of 75%. So trying to downregulate on that stress is a big piece of this. So that gets back to what's up with the non-openers. So if you look at the human literature, the biggest reason why individuals don't transform an empathic feeling into helping behavior is because they are so personally distressed. They cannot downregulate it. And I suspect that is the problem with most of the non-openers. So, and the prediction would be if you then gave them a chill pill, they'd go and open. Now, there is the possibility, and different people in the lab. So, Inbal thinks that this is will pan out. I'm a little more skeptical, but there is the possibility that we also have psychopathic rats. So a psychopathic rat is not, or a psychopath is not emotionally aroused by another individual's distress. And so in that situation, even if you gave them a chill pill, it wouldn't make a difference, and they would still be a non-opener. And those are experiments that are ongoing. It's a little bit hard to do experiments on the non-openers because it's only a portion of the animals, and you only know about it at the end of the experiment. So we have a little challenge there. Yeah.
But might they see each other as competitors? Like, might it be useful to find out if they're sterilized, if they be neutered, if that would affect their behavior?
Well, like so I don't really want to do the whole mating thing with the rats, but if they were competing for food, for instance, that would be a useful a useful tool to figure out what the worth is.
But might they also see each other as sexual rivals, and that they don't want to help each other because
These guys are not sexually experienced, so it's a lot easier to use them to use food as the source of rivalry than access to a mate. Yeah.
Just to clarify, when you say a rat is a non-opener, does that mean in every instance he hasn't opened the door for the rat?
It means he does not consistently open it. And so the typical non-opener never opens it. Some non-openers open it once or twice. They typically do it not with their snout. So they're not doing it. There's no evidence that they're doing it willfully. They're doing it by mistake.
Okay, let's turn off the camera and get to the real question. What does it tell us about us?
Right. So, so I actually was not, when science highlighted this, I was really shocked when I started getting these calls from journalists about, I don't know, the vermin. The vermin are nice. Who knew rats were so nice? Because I don't live in that world where rats are that different from us. In my world, it's an evolutionary continuum. And we are mammals. We're good mammals, and rats are good mammals. And yeah, we got a big cerebral cortex, and it allows us to do fancy things. But in so many ways, we are very akin to the rats. So I never, I just didn't get that whole thing. Okay, it had some sort of, I don't know, wide appeal for people who are scared of rats. But to me, what is the take-home message is what it says about us. What it says about us is that biologically, we are destined to help others in distress. And that when we do not do that, we are somehow suppressing a biological inheritance. And that's really, to me, the take-home message.
And stress suppresses that.
And stress at any time, we've seen, so we have another experiment that suggests that early stress, months before, or immediate stress, the injection that day, either of those are the enemy of helping behavior. Yeah.
I have two questions. First one,
Does anyone know if the science editors are openers or not?
Definitely openers. The science editor that we worked with was unbelievably wonderful and fabulous.
And the other question is, I don't really know the.
No, I didn't say that about the reviewers, by the way. No, they were great. Great.
I don't really know the literature, but I read Martha Stout's book about sociopathology in humans, and she suggests that 4% of the human population would be non-openers genetically. So you didn't feel there was a genetic component to the non-openers?
I never said that. I never said that. And I do think there's another thing that we have proposed has been to do a breeding study to try and make super empaths and on the other end, and see if on the other end, if we breed a lot of non-openers with each other, can we get the psychopaths out of that? Yeah, that wasn't funded either. But yeah, I think that that's a definite possibility. No, well, there has to be a genetic component because at the very least there's a genetic component via the genetics of anxiety. Okay, I know that anxiety affects this behavior. So, and we know that anxiety has a huge genetic component. Yeah, I mean, what doesn't have a genetic component? Yeah.
Did you ever give the rats a choice where they just, once they opened one, they couldn't open the chocolate?
This is the Sophies Choice. So Sophie's Choice was an experiment that we have wanted to do since very early on. We've wanted to do it for, I don't know, since about month 8 of starting in on this. And the problem is it's a little hard to explain that paradigm to the rat. And so we have never figured out how to explain it to them.
So they can't learn that once.
They could, but by the time they learned it, we're afraid that the opening or the non-opening would be a habit. And the habit thing is also very, it messes up some of the experiments that you could design in your head if it didn't become a habit. Yeah.
Just so I understand correctly, among the non-openers, there are 2 categories. There are perhaps psychopaths who could open, don't care to, and then the ones who are emotionally, if that's the right adjective, disabled, cannot do it.
They're overwhelmed. They're emotionally distressed in an overwhelming way, and what I'm telling you is conjecture. I don't have proof of either of those. They could all be psychopaths. They could all be overly anxious, but I suspect that the bulk of them are overly anxious, and that there may or may not be some smaller proportion that that correspond to the sort of callous, unemotional, or psychopathic phenotype.
Because it just seems like commonsensically they're an opposite ends of the spectrum. One almost no.
That's right. And so one of the ways to figure that out is to do a lot of other personality testing on the rats. And so you would expect that the bulk of the non-openers should be very high on anxiety traits, but then that group that's not high on anxiety traits and are non-openers, those are the candidates for psychopaths.
And is there a cognitive component where some of the rats
And then there's the stupid rats. And yeah, we don't have a great way to, we could do some sort of motor task to try and figure out who's the stupid rats. I'm not sure there are stupid rats. This is not like, I think one of the reasons this works is because it's so old-fashioned. It's a door. It's not an electronic lever. So the door hangs together. It acts like an object. It's nothing that is outside of the rat's realm of it's not outside of the rat's world. It obeys the physical properties of the world of the rat. I think that when you start using levers that they have to do either with their snout or with their hand that are electrically connected to some outcome, sure, you can teach them to associate that, but it never really makes sense to them. And I think that's one of the reasons it works. Yeah.
So do you, in your opinion, I know you haven't proven this, but if you think empathy is biological, do you think gratitude and holding a grudge isn't?
I have no idea. I'll tell you, but this is a really, this is why it's so fun to do this with so many students at all levels, because they can jump in with really great ideas. And here's an example of one which I thought was, we haven't done it. I'm not sure that we're going to do it anytime soon, but let's say we, instead of housing those two together, we housed about 6 of them together. And then over here were the other 4. Is he going to open it and let all the pals play, or is he jealous? So can we look for jealousy? I don't know. There's all these things. You can manipulate this paradigm in so many different ways to look for so many interesting things. And yes, gratitude. I haven't seen too much gratitude in rat world. Yeah.
If the non-openers are taught to open, will they still be non-openers?
How do we teach them? We're not teaching anyone. They have to, essentially what we're asking them to do is find a motivation within themselves to do this. And they either do or they don't. The non-openers don't. Either because their motivation is there, but it's covered over with too much distress, or because the motivation's not there.
No, I mean, if they, say if they learned to open for chocolate, would they, and then they were presented with the trapped rat, would they?
That's a good experiment. Yeah, that's great. Yeah, that's a great experiment. We haven't done that. It's a really good idea. Yeah.
No, these questions are wonderful, but I'm really interested in your findings. Is there more?
No, that's it. I can tell you about things. Thank you so much. You're not a plant. He's not a plant. But that's my grand conclusion: is that humans have this as their biological inheritance, and we're mucking it up clearly. Because for some reason we're not all getting along. And as far as where we're going with this, the only slide I have, and I'll show it to you, but I think your questions are better than this slide, is where you can go with this. You can go, we've talked a lot about psychopathy or its pediatric antecedent. Clearly, people with anxiety disorder are overwhelmed. They are going to tend not to be as helpful because they're so anxious. I think that this also is a potential model for autism. There are not that many models where one individual has to detect the affective state of another individual, which is really a core issue for individuals with autism spectrum disorder. So I think this has a lot of power to look at a variety of human disorders. And, in the end, it's just plain old interesting. This is fundamental human knowledge. That's very UC. And that is probably the thing I love about UC the most. Yeah.
Humans tend to form attachments to not only to other humans, but to other mammals.
Yeah.
Pets, dogs, cats. Yeah. Have you tested, or are you planning on testing whether rats would do this for any other mammal, like a mouse?
So let me just address 2 issues that you bring up. One is in humans, helping behavior has a strong dependence on whether you're in group or out group. And you can manipulate that. And some of the cool experiments, some of the most striking experiments have been, for instance, done in the United Kingdom, where whether you're a fan of the same soccer team as the person that just fell down will influence whether you go over and try and help that person up. Okay? Whether you're a Manchester United fan or not. Now, interestingly, there's no evidence for that in-group, out-group distinction in either chimpanzees or in children below about 3 to 4 years, suggesting that the in-group, out-group distinction is a cultural one that we have now imposed on a biological process. And that's something that we're interested in doing with the rats. And actually, that experiment is scheduled for July. So we'll be able to see whether the rats have any signs of in-group, out-group. Now, as far as cross-species affective sharing or empathy, I can tell you, there's no question in my mind that it exists. The rats know when we're stressed. Okay? And they, and I'm sure your pets know when you're. What is that? So, but have we figured out a way to test that? Not so much. I have to actually get IRB approval to give my students Valium to see whether the rats act differently when the students are on Valium or not. These are kinds of things, but it's interesting. I have no doubt that exists. Yeah.
The piece I find myself thinking about is the counter effect of fear or risk. So what if this is an enemy rat trapped inside the cage?
So we had the bully experiment. There's a paradigm in psychology called resonant intruder, and what you do is you put a little rat of one friendly strain in with a big rat of a not so friendly strain. Big rat beats up on little rat. You separate them so that little rat doesn't get killed, essentially. You separate them with a little chicken wire and leave them there for half an hour. They have to live in fear of the proximity of the big bully. And you do this every day for 2 weeks, something like that. Okay, after that point, this little rat is just a little disaster. They're just an anxious mess. Everything changes. Their bladder changes. The pattern with which they urinate changes. Their hormone levels change. Everything changes. They are a beaten down, not happy rat. Moreover, when they see the bully rat, what do? They freeze. And we can't get over the freeze. So, a frozen rat is not going to open the door, but not for an interesting reason. He's just frozen. So we're not doing that experiment. We want to do that experiment in some way but we don't know how to get a bully that won't make them freeze. So we're kind of stuck. But good experiment. It's a great experiment in theory.
So that means to me that rats don't all get along. I mean, you have the question up there, why can't we all just get along as if humans were, something special? Apparently rats are the same way.
Rats, so if in rat land, it's all about weight and size. So they'll get along as they're roughly within 50 to 100 grams of each other. But once they start out weighing each other and they've never met, no, they're not going to get along. I take your point, but in general, if they've lived together and they've grown up together, they're going to get along. Yeah.
All these, you told me said one time that rats don't like light. They don't like to be in an opening. Have you tried varying the illumination level for the experiments?
One of the criticisms that we got, which I don't believe for a second is true, but this is it, which is that the trapped rat is making so much distress calls, letting off so many pheromones, something is making the free rat so unhappy that the free rat opens the door for the trapped rat just to shut him up. There's a really easy test of that, which is you put the trapped rat in one arena, and then you have a little pathway that goes to a separate arena, which is soundproofed, and they can leave if they want. And that actually that experiment is starting in 2 weeks. They're never going to leave. I can guarantee you, they will not leave. They'll sit by the trapped rat because they're very concerned with the trapped rat. But you know, maybe I'm wrong. There's some infinitesimal chance that I'm wrong, but and in that situation, you can start to dial down or up the attractiveness of the two arenas. So, for instance, you could make the withdrawal, the escape arena, dim, and now is that enough to draw them off? Well, they say, okay, well, I really care about you, but I so much want to be in the dark, so I'm going to go off to the dark. So you can start to weigh those things, and that's something that we're definitely interested in doing. Yeah.
You tried giving the non-openers anxiolytics?
Yeah, that's. We actually have thought about doing it with the group that we're doing right now, and we have another little problem. This is bizarre. I mean, this is how science works, okay? So these experiments take a little while. What happens? What do rats do over time? They grow and grow and grow, and they get too fat to sit into the restrainer. So we actually cannot continue to experiment because some of the rats are actually a half a kilogram. They're too big. So what we're now going to do, because we want to do that experiment, what we're now going to do is get them on an 80% diet. So they'll just grow, but they'll grow a little slower. Yeah.
I know there's an endless number of permutations. What about diffusion of responsibility?
We thought about that. So we've done 2 rats in an arena with an empty restrainer. And they open it quite a bit, just because when there's 2 rats, there's so much more activity. Now the center is not so scary because you got a pal. I don't even know how they do it, but they're just, you have twice the activity. I don't know that the diffusion of responsibility experiment will work, but it's something that we've thought about, and down the line we may try a different version of it. It's methodologically it's got some hang-ups. But you guys know what he's talking about. If a street full of people see somebody screaming for help, no one calls the police. But if one person sees somebody calling for help, they do call the police. So that's diffusion. You know, if you're one of a crowd, you assume that somebody else is going to take care of it. Diffusion of responsibility, versus if you're the only one, you feel responsible and you actually do something. But yeah, it's a cool idea. Yeah, David.
There's one confound with diffusion of responsibility. That's that if someone is calling for help in a crowded area, they're not training on each person who they're sending a targeted distress cry to quite as much as if they were directing it to one person at a time. I'm not sure how that could be controlled for too, but
yeah, there are a lot of permutations. Yeah, I think if bottom line is we've chosen a few paths to pursue first, and that's what we're doing. But there's no question that there's endless other ways that or other directions that would be absolutely fascinating.
One thing I'm clear about is if I'm in trouble, I want to be around people who are not under stress.
Right. Yeah.
Is there any way of determining whether all the rats you use are physically capable, equally capable of flipping that?
Physically capable, I'm sure they're all physically capable of it. Are they all cognitively smart enough to make the connection? I actually even think that they are, but I don't have evidence for that. That's an outside possibility. That we have stupid rats. Maybe. It doesn't take a whole. It's a sort of a ballistic movement. There's not a whole lot of cerebellar coordination that's required in this. They can make a big movement or a little movement. It still works. Well, thank you all very much. It was delightful.